Welcome everyone. Thank you so much for coming. This is Unicode with PHP. We will talk about the history of Unicode, what Unicode is, and why we have it, because it sounds so annoying with those names and all the things. Before we start, my name is Ayesh Karunaratne, and I work as a security researcher and I do freelancing work. You can find me on all the social media, and the slides of the talks are available here. Like when you talk about Unicode, there's a lot of things that so many abbreviations, UTF-8 and ASCII characters and byte order marks. There are so many things that like it doesn't make sense. Where do we start? So we try to start from the things that we have in normal lives. And one thing I find really interesting is Morse code. It's a way to represent English letters and numbers using. If you want to send a message to someone else, you can make there's a short beep, and then there's a long beep, and then there's a silence. Using the three, you can send messages. For example, to send a message EA, you just send a short beep and then the longer beep, and someone seeing this message from the other side, they can write the same things back. If it's E, that's a short beep, T is a longer beep, and the list goes on. So to send a message, you can see things go. You have the representation for C, and the representation for A, and representation for B. It's a simple stuff, but if you think about it, it's what we call character encoding, because you have the characters, and then you have a different type of signal that you have to send, and the process what we call encoding, and then you can get the real message back with the process what we call decoding. So the question is, how do you encode characters in a computer system? Because like in Morse code we have the short beep, but in here we have zeros and then we have ones. So to solve this, if you go back in time, 1963 in the US, because everything happened in the US for some reason, there was a standard called ASCII, which stands for American Standard Code for Information Interchange. And the basic idea is that they still use zeros and ones, because that's the only thing we have anyway. And we have the numbering systems in computers that we call numbering systems, and each of the signal is called a bit. So like in Morse code, you send a short beep, and in here we have zeros and ones. And they have representation. This is simple binary numbering systems, 2 to the power 0, 2 to the power 1, and they mean 1 and all the way to 64. So this message means 61 of ones, so 64, and then you put them together, that's 65. We also use hexadecimal numbering system, so 16, and then each signal means 4 bits in the binary system. 16 to the power 0, 16 to the power 1. This is hexadecimal notation. So for the ASCII standard, in 1963, someone sit down at a table, and then he was writing, I'm going to assign the null character to 0, which was okay. The null character is used in computers to indicate that this is the end of a string, or the fact that there's nothing in it. To A, they assign 65. It's just some arbitrary number. Someone was sitting down, I'm going to decide, I'm going to assign 65 to A, like Morse code. B is 66, C and D, they also had different numbers assigned for lowercase characters, A, B, and C. In fact, they had the whole specification that defined the English letters, also lowercase, some numbers, mathematical symbols, and then there were things we called control characters, which meant the enter key, the escape key, all the signals for delete key, or many things. If you look at a keyboard from the US, you can still see the mappings between the basic ASCII standard, 128 characters assigned to different keys. And the times goes on, people started to use this standard because computers were there in the US most of the time, and people were happy about it. But when the time goes on, people had the 7 digits in ASCII, but people start to use 8 bits as one unit of memory storage. So suddenly you have one more bit, which could mean you can store 128 more characters, which was pretty good. But here's the thing, when the time goes on, because we can't have the same standard, people were thinking, okay, I'm going to include more characters. Because if you go to Hungary, they have a whole bunch of characters. In France, to say "sawa," you have a different C with a diacritic under it. It doesn't gonna work that well. Said everyone, we need more characters at the same time, and people start to create standards. In the US, there's one called ISO 8859. One more version of it. There's another version. In fact, they had 15 versions, and the whole world started to create more standards everywhere. And this is a whole mess. I mean, how do you send messages between each other? So yeah, when the time goes on, there were over 400 character encodings, not compatible with each other. So this was a real problem. In fact, there was a word in Japanese called mojibake, which means if you send one document to someone else using a different character encoding, it looked totally different. So this one, this is an extract from Arabic, and depending on the character encoding used, it's just garbage everywhere, different garbage in different character encoding systems. So how do you fix this? And people start to make more standards all the time. To fix this, again, 1991, the US, they started this consortium called Unicode Consortium, and one thing they had to realize is that 1 byte isn't really enough, because you have 256 characters. There's no way you can encode all these characters. Let's use 2 bytes. You have 1 byte that includes 256 characters. If you start to use 2, that means 65,000 characters. That should be good enough, but not really. Because if you write NL in ASCII, A is 65, B is 66, and then you have N is 78, L is 76. Now you have the bit representation here, but if you combine these bytes together, this is 20,044. This is not the best idea, because if you assign different numbers, this is Chinese Wu character. Which one is it? You don't know. So this one is N, and this one is the Chinese Wu. So if you have a byte stream on the database, and then if you are searching for N character, and if you actually meant to type Wu character, you will find N character and L character there. So that's not going to work. And the other idea is that this same idea, it's not compatible with x16 ASCII documents, because you had 20 or 30 years of ASCII documents. It's not going to be compatible with each other, and they had punch cards. Do you really want to go all the way back and take the punch cards and use 2 bytes? No, right? And you have multiple character representations from the same character, depending on how many bytes you use. So not a good idea. And the other argument was that 65,000 characters, they're enough. Again, not really, because we have 1,000 Latin characters, we have Cyrillic characters, Greek, Arabic, and Indian characters. I want to speak one of these languages. And Korea, they don't have characters, they have different characters put together and then make a whole word. So 11,000 Korean characters. If you put Chinese and Japanese characters as well, that's 42,000. And we forget about all the small scripts like Khmer or Myanmar. Let's go to add more mathematical symbols, scientific symbols, and currency symbols as well. So yeah, you gotta need more characters, more than 65,000. So the Unicode Consortium, they had different goals. One is that we should have consistent character representation. And the other one was that we need to encode them, but it should be compatible with existing documents, because we have about 40 years of documents that I'm not going to change them. No one's going to change them. And we should be able to handle all the characters in almost every writing systems, because some writing systems you have to write from right to left, and some other languages we write from left to right. Some characters, some languages you have to write from top to bottom, and it's weird. But the goals before they start to even describe these character encoding systems was that we had to find what's wrong with it. So the other one was that it should be versioned, as in we should be able to add more characters to the same standard without changing anything we have in the past. So in the Unicode in standard, we have 3 character encodings. They're called Unicode transformation format, and then there are 3 UTF-8, 16 and 32. We will talk about them later. And they also have 1.1 million character code points. Think about code points as a slot that you can put individual characters to. So from here you can see the hexadecimal values, and then the last bit, each of these cell or cage, if you will, you can put my characters. But here's the thing: if you took at the first 3 lines, they are actual characters, and this one is letters from my alphabet, and this yellow stuff, they're not characters. They are more about the additions that you can combine these two together, and then you get a letter, one specific character. So these code points, they are in a way they are characters, but not really. And then you can put emojis, or you can these numbers, symbols. So it can define 1.1 code spaces so far. It's not a technical limitation. It's about it has 65,000 plain, and then we have 17. It doesn't mean we can't add more to it. So this is extensible. If you find some alien civilization with Unicode characters, that's a problem. But other than that, it should be okay. So far, we only use 137 characters. No one knows all of them, so it is okay. And it covers about 150 writing systems. So every writing system you know: English, my language, Sinhalese, Khmer, Thai, Vietnamese, Chinese, Batak, all these character systems, they are there. Unicode characters, emoji characters, they're part of Unicode characters. So this is pretty consistent, and it can be versioned. If you have new characters coming in the next year, yeah, sure, we can do that. If you have to write a new language for Mars, yeah, we can do that, because we have 1.1 million code spaces. And this is way that you can encode Unicode characters. It's pretty simple format. If you see a U here, it means this is Unicode, and this one is a hexadecimal code point that we saw from the chart before. This is just a notation. It's just a way that you express this is Unicode character. If you have 5 digits, because we sometimes go for 1.1 million, you can use 4 bits for positions, but usually we use pad with zeros to make sure that the number is 4. The first one is UTF-8, and this is my favorite, and this is the most important thing. So the idea is that we don't change anything from ASCII. 1963, the ASCII standard, we don't change anything. This means all the 70 years of history, we can use them. So the ASCII standard, they use the first 7 bits, but to use for the first 127 letters, we don't use this byte, the first 0. So this is totally compatible with existing ASCII documents. The zeros with this is ASCII character. And if you have to encode more letters, like after 128 position to 2048, this is 2048, that by convention we use the first 3 bytes to say that how many bytes we have in the character. So if you see 2 ones, it means for this character, one single character, we have to use 2 bytes, and the second bytes and third bytes and the fourth one, they always use the 1 and 0. This is confusing, but I have some examples. And before the numbers, these indicating bits, put the rest of the bits together, and then you get the number, like the final value. The first one is the ASCII characters. You can see how you can encode A in byte stream. It takes just 1 byte. And the pound sign, you have to use 2 bytes to this, because the number assigned is this one. So by convention, we said that this byte has for this character we need 2 bytes. So we use 2 bytes, and then the first one means 110, means this is 2 bytes, and all of the bytes, they start with 1 and 0. this is one of the characters from my language. You have to use 3 bytes because we are special, I think. So this one means we have 3 bytes, and then each byte it has 1 and 0. So when you say 3 bytes, it includes the first byte as well. And for the poop emoji, you have to use 4 bytes. They are more special than my language. No, I didn't do it, but someone decided. So you have to use 4 bytes, 1110. So it means we have 4 bytes. Order of the rest bytes starts with 1 and 0. This is good. There are so many advantages, but not UTF-16, because UTF-16, the idea is that for all the characters, I'm going to use 2 bytes. But when people start to more than 65,000 characters, you have to use 4. So you don't have any of the advantages. You can't say UTF characters always take 2 bytes. Sometimes they take 2. And you can see by the convention, they use 110, 110, and the next byte is 110, 111. This standard is horrible, and if you don't use it, we can't be friends. So UTF-13, 32, the idea is that I'm going to use 4 bytes for every character. Don't ask me why. This is so spacious, and you can see how much space that you waste. This is a whole bunch of zeros, and just 1, followed by zeros, and then just 1. So you can see how wasteful this is if you think about in terms of bytes. So if you think about all the things back, UTF-8, it's compatible with existing ASCII documents, which is really nice. You don't have to do the same work for 70 years of documents, and it doesn't waste space, because for poop emoji you need 4 bytes, but for regular English characters, just 1 byte. You can argue that the number of bytes you use is not important, but we are talking about something that has been happening for 1992 and all the times back. My first computer had 32 bytes.
Just a reminder, for the second example, the bound,
Yes.
those last 2, now they're not switched. So it says it ends with 1100, but in the example.
Yeah, sorry. That's a mistake. Sorry. And but the problem is that the character length isn't fixed. So you have a file that's 8 bytes. How many characters do you have? We don't know, right? You have to inspect individual bytes and see if this is one character or this belongs to a different character. So that's the one downside. UTF-16, they don't have any advantages. This is horrible. It takes 2 bytes, but not really, and it wastes memory because it uses 2 bytes when it's not necessary, and it's not compatible with ASCII. UTF-32, one advantage is that we can use 4 bytes to this, and then it's always 4 bytes. But the downside is that it wastes memory, like 4 bytes for every character. I'm not going to do that. But this is faster because you know how many bytes you have for individual characters, and it's also not compatible with ASCII. So people started to use UTF-8, and you can see from the blue line, the usage just goes up, and the other ones are Western Europe, and GIS is a Japanese character encoding system, which still is being used in Japan for some reason, but the usage kind of goes up. And now today we have over 93.5% of web pages, they always use Unicode UTF-8 character encodings, which is quite great. And the Web Hypertext Application Technology Working Group, that's the longest abbreviation I know, said you have the UTF-8 for all the things. So we start to use UTF-8, and we come to the second part on how you can use Unicode characters for developers. Like, this is the juicy part. So the first one, how do you write Unicode characters in PHP? Well, you just write it. You can just start variable, and then if you can type the Unicode character, just type this character. But if you have to write a specific Unicode character, you can use this syntax. You start from double quotes, it must be double quotes. Single quotes never work. And start with the Unicode code point and wrap this with curly braces and then start with the U. So U means Unicode character. This is a convention, and you can see in many languages they actually use this pattern. So this is how you write Unicode in PHP. But just make sure that you always save your files as UTF-8, because in PHP it assumes that your files will be ASCII or UTF-8. Because ASCII letters, they are compatible with UTF-8. There's no problem for PHP that if you have ASCII letters or UTF-8, it's just 1 byte for the same characters. In PHP Storm, there's option to change the character encoding. There's one in Notepad++. Almost every text editor, they have a feature to change the character encoding. Because we are PHP developers and good people, use UTF-8 all the time. And there are many websites that even encourages you to use UTF-8 all the time. Here's an example. If you do encode a PHP document to UTF-16 and try to execute it, it doesn't work because in UTF-16 there's a thing called byte order mark that basically says that this is UTF-16, and PHP doesn't see the PHP tag, because for each character you have to use 2 bytes and then you have 8 zeros. In UTF-8 this is a null character, so it's just not going to work. So sometimes if you have a script like this, you probably have UTF-32 or 16, which is unfortunate. So change them back to UTF-8 like this. The other thing is, how do you write Unicode characters in HTML? Like HTML in PHP, you just type it. This is the first letter of my alphabet and it's part of my name, and I like to use this character. You can also type Unicode characters like this. Start with the £, the hash, and then you can use the Unicode point, that's the decimal value. You can also use hexadecimal values if you put the small x here, and then you also can save the files as UTF-8. You can also tell your browsers that you are using UTF-8. It's pretty easy. You just send this header that says the character set we use today is UTF-8. Most of the browsers will do this for you, but it's a best practice if you just send the header by yourself. The other one is, this is the most important part I have in the slide. The thing is, for PHP, every character is a byte. So PHP says that byte is one character, is interchangeable for PHP. But we just saw in UTF-8 you can use 1 byte, maybe 2, maybe 3, or sometimes even 4. So PHP, if you see 4 bytes, for PHP they think it's 4 characters, which is obviously wrong. So I have one example. If you want to check the length of a string, we can use the PHP strlen function. But if you have the euro sign, which takes 3 bytes, but in our case we expect this to be 1, right? This is euro sign is just 1 character. Run it, PHP says this is 3. This is bad. If you try to take a part of a string outside, you can use the substring function. So in this case we try to extract the 1025, the price of this product, but PHP will say no, this is a binary character, because what we do is for the euro sign in UTF-8 we have 3 bytes, but what we try to do is we split a character in half and then try to extract the next 5 bytes from there, which isn't really a real character. And this is a way that PHP represents the bytes you can use in a number, in a variable. And then there's another one called string array analytics. You probably don't do this. If you have a string and you can extract different characters from the string as if you're accessing arrays. So you have this one, and then you expect to put your tongue out, because there's a 0, 1, and 2. But for PHP, we expect this one. But for PHP, not really, because when you say the third byte, the 2 is the third byte. It's part of the emoji character, and it's not a real character. So this is also wrong. How do you fix it though? In PHP, there's an extension called MB string. MB stands for multi-byte, and it has a whole bunch of functions that help you to do this. For string length, instead of using strlen function, you can use MB, the same function, but you just put MB underscore. It will give the correct result, which is 1, and that's exactly what we expect. Substring, we try to extract the price. Instead of using this one, you can use MB underscore substring, and then it's the same code, same number of parameters, and then you get the value that you expect. For string array index, because this is a PHP core feature, there's no solution to do this with MB string, so you kind of have to use the MB substring function to extract the character that you expect. This example, many people don't use this, but I decided to include it anyway, because just to say that you can't search and replace all the string length functions with MB string length, because in some situations we don't even have a direct solution to this. So just keep in this mind. And MB string, they have a whole bunch of functions for almost every string function we have in PHP core. So try to use them whenever necessary. And with MB string, there's a feature to overload the regular functions, which basically means when you call string length function, MB string extension will automatically replace this function for you, and it's considered a bad idea, because if you try to write some open source code, you don't know if this is overridden or not. So it's not your code is not portable after, and this is the feature. It's not enabled by default. So if you're thinking about enabling this feature, please don't do it. And this feature is going away in PHP 7.2. It's deprecated. It's probably go out in PHP 8. So this is a good news. But the thing is, all these MB functions are slow. Are they though? So I did a test run. So we have the first one is we tried to count the length of these strings, the euro sign, which takes 3 bytes, and then we have the counterpart with MB string length functions, and they run this 1 million times. You can see these functions, they only take less than half a second, and these functions, they tend to go way more, because the last one, it has 100,000 euro signs, so it had to count a lot of bytes to see how many characters they have, so it takes more time. But you can notice it's going linear, as in how many characters you have, the duration tends to go a lot more. So if you have to count the length of a string or use MB functions, just make sure that it's not the fastest solution, but between doing something wrong and faster, or between doing something correct way, and even though it takes time, I always pick this one, and it goes to go linearly. And PHP also has UTF-8 encode and decode functions. They're horrible functions. Don't use them at all. And if you wrote these functions, I'm so sorry for saying this, because what they do is it doesn't magically make your strings work with UTF-8. It's just a way to encode this ISO 8859-1 character encoding to UTF-8. Like a few slides before, we saw that there are over 400 character encoding systems, but that's it. That's the only character encoding that you can encode from. So not really useful. I've been working with PHP for about 8 years now. I never had to type this, not at all. I was stupid. I typed it a few times, but now that I know better, I never have to use it. But how do you detect and encode characters in PHP though? Because UTF-8 encode doesn't work. The solution is the MB string function extension. It comes with a few functions that you can detect the character encodings used in a given letter, a given string, a document or file, and then you can convert the character encoding systems to whatever the system that they were using in the old document to UTF-8. So you probably won't have to do this for all the inputs because we use UTF-8 today. But if you find a document from 1995 or something, and if you have to convert it, this is how you do it. So and the other thing is regular expressions with Unicode. This is one part I'm super excited to talk about because I never saw anyone talking about it. But the thing is, you can use Unicode characters in regular expressions. You have to make sure to pass the Unicode flag to tell regular expressions that we have Unicode characters in it, and you can use the code point. Like in PHP, we used U and then curly braces and then the hexadecimal value. In regular expressions, we use X character. Don't ask me why. And then you put the hexadecimal value. You can also find a range of characters. So this one is basically saying we need to find any letter between A and D, because in A the ASCII value is 65, which is hexadecimal 41, and D is hexadecimal value 45. So we find all the characters between 41 to 45. So A, B, C, D, we just find them. You can type the regular one as well, which is this one. But if you want to look cooler, you can use this one. But the thing is, if you have a whole range of Unicode characters that you don't even can type, you can still use this syntax because it will find all the whole range from the number. So it can include English letters, currency symbols, and there are all the Unicode characters that you can think about. In fact, there's a cool trick. There's one called in Unicode specification. They have character units, which, for example, you can define one group of characters. This group is currency symbols, and this group belongs to this language, or this group is emoji characters. You can search for this whole range using these regular expressions. I have one example. So SC means symbols for currency. Do these regular expressions on a string, and it can find all the character symbols that we use in today. This is pretty cool because euro signs or the pound signs, the dollar signs, you don't have to type individual characters. You can find all the characters that belong to the same Unicode group. You can even type a language name. Sinhala is my language, and you can see that it actually found this letter. If you convert this lowercase p to uppercase p, it will find all the inverse characters. This is pretty standard Unicode in regular expressions. The lowercase s is space, the uppercase s is everything but space, and regular expressions follows this pattern. And the other one is how to use Unicode characters with MySQL. Well, before we talk about this MySQL, I have someone that I talked with before. I have to explain what these things are. The first one is a char set or character set. The basic idea in MySQL is that we define this character set, and MySQL always makes sure that all the characters they store in the database, it belongs to this character set. So for each database, each column and each table, there's a value that we set a character set. There's another one called collation, which basically means the rules we have to sort different characters. Because in English we have A followed by B followed by C, but in different languages we have different rules to sort these characters. For example, in my language, you can combine different things, different formatting strings together, and it should be still the same character. So in the Unicode standard, the characters go in different way, but in our sense, it should be sorted in a totally different way. So you can set a collation, which is basically the set of rules that you can sort these characters. We'll have some really good examples, and you can have more than one collation for each character set. Because MySQL has so many historical reasons, sometimes you will find configuration options that doesn't set this character set. We will talk about this more in UTF-8 MB4. But if this is not your default configuration, just make sure to change all these the client's character set used, and the database character set used, and the services character set used to UTF-MB4. When you connect to your database, we use PDO or MySQLi. Don't use MySQL functions. You can set this character set as UTF-8 MB4, not UTF-8. This is important because MySQL is stupid and Oracle is stupid and all these things. They had a character set called UTF-8, but it didn't support 4 bytes, because UTF-8 we know that we can go for 4 bytes. But someone in MySQL Oracle was thinking, yeah, we should probably use 3 bytes and that's it. That was stupid. So when they realized it, they couldn't change this to UTF-8, and they couldn't change the functionality. So they created a new character set called UTF-MB4, which means multi-byte, and 4 means it uses 4 bytes. So every time you see UTF-8 in MySQL, just keep in mind you have to change this to MB4, and don't thank Oracle for it. So you just make sure UTF-8, and it supports all the characters in Unicode standard 1.1 million characters. You can use all of them. So you can convert your databases that you have. This is a one-time process, and you can see this example in almost all blog posts. I just copy paste from somewhere, but the basic idea is that the first one, it says we are going to change the character set to UTF-8 MB4, but it doesn't mean it will change all the existing tables and columns to UTF-8 MB4. This affects only new ones. So we had to go through each table. Just do this for all the tables you have, and convert the character set to UTF-8 MB4, and then set it to use Unicode CI collation. This includes all the rules that you have for Unicode, and go through individual columns, which you probably have for like 200, and then you have to change this. But keep in mind we use 191, because if you know about MySQL indexes, there's a limitation of the number of bytes you can use in individual index, and the limit is 788. Because we use 4 bytes now instead of using 3, you have to make sure that your columns can contain these values. So if you have a character that uses 255 characters, you probably can't change this back. So you have to sometimes go back and trim the length of the columns. And Unicode Security. This goes faster because most of the Unicode characters you see, they look similar to each other, and there's one that we call pay attacks. This is not an L, this is a capital I letter, but it looks like PayPal, right? So one of the attacks, most of the UTF attacks in fact, it includes these homograph attacks, which basically means you type something else, but it's not the same characters you see in English, but they look so similar. And in fact, if you look at the title of the talk on the card here, it has different characters, but it looks like PHP. But if you search for PHP letter, PHP string, this wouldn't come up. So just make sure to sometimes you will have to convert them back to regular characters, and you can also use malicious fonts. So if you find some Russian website that offers free fonts, they probably switch the representation of characters between the numbers, because you can say in the font that for the 65 ASCII 65, instead of A in the font you can change this to a P. So when you want to write my name AYESH, I might write PYESH, which is a curse word in my language. And when you compare text, just make sure, because A and it looks like A, it's not the same A. So when you compare these strings, they probably wouldn't be the same. And when you open files with PHP, I had a whole different section, but I didn't have enough time to explain all these things. Just make sure that when you call these files, fopen, fseek, and all these files, you will see a parameter that you can send the length, like read 400 strings, 400 characters, but it doesn't mean characters. For PHP, it only cares about bytes. So when you say I need to read 400 characters, for PHP it actually means 400 bytes. So just make sure that keep in mind that you are always dealing with bytes and not individual characters, and they are not the same. This is why one of the reasons why I love Unicode, and one of the reasons why I come here, and I do most of my work with Unicode characters. I don't do anything, but I work on translations and most of the character development in my language, and that's the reason why I could come here. And I feel so honored to have spoken to you today. So you can have some you can have a look at all these most of the things that I learned from, especially this polyglot gathering. It's a conference about Unicode characters. Sounds interesting. And Ken Thompson is one of the people that started the first Unicode consortium in 1991, and he has said so many things that you can use in slides, so good quotes. And there's a Twitter handle called Fake Unicode. They tweet really cool stuff. I even have notifications on, really nice jokes. There's some YouTube videos, and then there's this website is a rant for the most part about saying you should use UTF-8 everywhere, but not UTF-16 or 32. So we have kind of friends because we use UTF-8 now, and that's about it. So if you have any questions, I still have like 4 minutes or 3 minutes, I think.
You said about converting MySQL tables. Do you have to do it on each level, database level, then table level, and then each column level, or can you, if you do it on table level, then all columns are also?
So his question was, do you have to convert each column to UTF-8 MB4? But unfortunately, you have to. But you can use a script to, because there's a table called MySQL schema that you can extract all the names of the tables and columns, and then you can run a loop to go through all these things. For most of the frameworks, I think they have some sort of upgrade script that they can convert them to UTF-8 MB4. And also it's only supported in MySQL 5.5, which you shouldn't be using. Like just try to use at least 5.7 or 8.0. I didn't mention the version names because those versions are really old. But if you try to convert in the older version, you will get to some troubles. So just make sure to go through all the columns, all the tables, and all the databases you have, and try to catch all the exceptions, because there might be. And that's it for me. Thanks so much for coming.